This is Jay McCarthy from PrimeVault in our architecture series talking about some of the trade-offs and options that are in the custody space. Now, one of the main things that a custody provider needs to do is they need to have a strategy for storing and interacting with keys. One of the main ways that this is done commonly is to have the key stored in some safe place. So when individuals hold secret keys, they typically store them encrypted on their device. Maybe they use an air-gapped device like an old laptop or a hardware wallet. But when it comes to institutional solutions, the most common tool that's used is called MPC. MPC stands for multi-party computation. And the idea of a multi-party computation is that we have some algorithm that we want to run. For example, a key-based signature algorithm. And that algorithm, what it does is that it normally consumes some input, let's just call that X, and it produces some output, let's call that Z. And when given X, it produces Z. So X would be like the transaction, Z would be the signed version of that transaction. And typically the algorithm will have some other information that's part of the input that's somehow secret or protected. For example, maybe the key K. Now that describes a normal computation. And normal signature computations are defined as being executed by one person. So one person holds the transaction X, the key K, and then when they run it, they produce the single output Z. And the idea of multi-party computation is to take this one computation and break it up so that multiple people are doing it simultaneously. And these multiple people doing it simultaneously, they're not doing it in a way that's like producing redundancy. So if, one of them, they're doing it in a way where each one of them contributes information such that they couldn't do the computation on their own. And in fact, no one could do the computation on their own. So a really simple way to imagine this is to like imagine taking the key and just splitting it down the middle into the even bits of the key and the odd bits of the key. And we take the core algorithm that produces the key signature and like I sign it, or rather I produce the part of the signature that's related to the even bits, and then you produce the part of the signature that's related to the odd bits. And since I have the even ones and you have the odd ones, we can't do the computation on their own. We need to come and work together to do it. And we produce the ultimate transaction, the ultimate signed transaction afterwards. Now, this intuition of splitting the key down the middle is a useful intuition, but the details are just completely wrong. But that's beyond the scope of this conversation to go through those details. But part of the reason that those details are wrong is that in splitting the key up, we actually typically want to divide the key up into many, many pieces. Let's say that we want to divide it up into 8 pieces. And we also want to make sure that we can have a quorum that's not all 8, for example, to be able to produce it. So maybe we'll split up into 8 pieces, but any 3 pieces can come together to produce the signature. That's a really common way that these multi-party computation protocols work. Furthermore, when we say that we have the key and then we separate it out, let's say into 2 or 8 pieces, something like that, that implies that at some point the key was in one place. And when the key was in one place, we separated it. But actually, most MPC algorithms, they never actually produce the key. The key never exists in one place at a time. It just emerges from the properties of the algorithm. Now, these security claims about MPC protocols are the main thing that's been kind of the currency of the realm around custodial approaches. Everyone talks about, well, we're going to use this MPC algorithm. It was published in this research paper. Look at what's so good about it. Look at these authors. Aren't they so smart? Look at these security proofs. Look at our implementation. We've had our implementation audited. Isn't that so reliable? And all the emphasis is on how if I run this MPC algorithm and I have part of your key and you have part of your key, then I can't do things without you. I can't go produce transactions without you showing up, and I can't and giving me your part of the key share. And the main security argument that custodial holders base on is that they chose a good MPC algorithm. And isn't that great? Now, unfortunately, there are certain practical problems with using MPC in the most obvious way. And what I mean by that is that the security usability trade-off that we talked about in our last talk shows up inside of these MPC solutions. So for example, imagine that we have one Ethereum wallet and our organization has 10 employees. Do we have one version of the key where the custodial holder holds the even bits and then the company collectively holds the odd bits? And then those odd bits are themselves shared among 10 people? Or do we instead have 10 versions of the key where there's the version for J, there's the version for K, there's the version for L, and for each one of those, they have half and the custody provider has a different half? That is a coherent way to do it that would allow us to look at particular transactions and determine which user, they came from. And of course, if we did it that way, one of the major constraints that we'd have to prove is we'd want to prove that even though I the custody provider, have 10 different halves of your key. I can't like combine those 10 halves to figure out your real key. And similarly, the company can't take their 10 copies and figure out the entire key either. And so when MPC systems work this way, they have that original problem. Now, another sort of practical issue is that one of the main reasons people use custody providers in the first place is because they're nervous about holding and managing their keys. Well, like, what is the key? Is the key the actual private key for their Ethereum wallet? Or is their key a more abstract thing, which is like the thing that gives them access to their funds? And if the thing that gives them access to their funds is actually half their key, then they should actually be just as nervous holding half their key as they are about holding the whole key. Because if they need that half to get access to their funds, and if they make a mistake and use it incorrectly, then they should be worried about that. So because of that, it's really common for custody providers to have a quote backup of your key on the premises. And if they have a backup of your key on the premises, then they actually have your old key because they have their copy and they have a backup of your copy, which means that they have the whole key. But if they don't have access to your backup, then you don't have access to your backup in the event that you need it. And so any custody provider that's offering you the ability to, back up your key in case of a disaster where they manage it, they're essentially a centralized custody provider that's just using MPC as window dressing around what they really do. Now, in addition to all of these practical issues of actually dealing with the keys and the shares, one problem that faces practical MPC deployment is that under what circumstances the other side, meaning the custody provider, going to use their key share. So presumably you're only going to use yours when you think that it's right, but they can use their side of the key under any circumstances. So one of the things that they should do is they should make claims and promises to you about when and why they use their key. Those promises are the policy that manages the interaction with the key. And our opinion at PrimeVault is that many of our competitors treat this policy very, very lightly. They don't make the same sorts of high integrity security claims about the policy as they do about the MPC algorithm. They prove properties about the MPC algorithm, but not their policy evaluation. They don't allow you to ensure that only certain versions of their policy evaluation software get run in your transactions. They don't allow you to authenticate the policy engine itself. And we think that this is a major mistake because that policy engine, it is really the thing that's controlling access to your funds. Yes, the MPC algorithm is controlling access to your keys, but their policy engine determines when and if they use their half of the key. A way to think about it is that the MPC algorithm just makes it so that your funds are protected from like a hacker or a rogue employee at the custody holder. But they don't protect you from your own mistakes, meaning that you accidentally sign things incorrectly. Your own employees make wrong decisions about what kinds of transactions are made. Hackers taking control of your interface and submitting and having you submit transactions that are not truly authorized. Those sorts of things are only protected by there being rules in place beforehand under which the custody provider will use their half of the key. And so at PrimeVault, we think that the policy is paramount. It's the most important thing. Yes, the cryptography is important and useful, and MPC is a useful tool in providing that kind of integrity, and we definitely do all the normal things there. But more importantly, we spend our time focusing on the policy itself. Can you express the rules that you want about when your key can be used? Can you allow that policy to change over time without any loss of security? And can this policy be a transparent thing that you, your employees, and especially your non-technical decision makers can actually understand? And this is one of the main things that PrimeVault provides special compared to some of our competitors. Now, in a future talk, we'll talk about some of the other differences in our security architecture. But at a high level, what we've talked about today is how most commonly custody providers use only multi-party computation and think that is the end of the story. Whereas we at PrimeVault know it's not the end, it's just the beginning of the story, which I'll continue next week for you. Thank you very much for your time today.